Welcome back to my YouTube channel. Previously, we have covered Firebase Firestore database in detail and we have performed all the CRUD operations there. Now it's time to explore the real-time database offered by Firebase and Flutter. So before moving to that, if you haven't liked, shared and subscribed my channel, please make sure to do so and don't forget to press the bell icon as well. Now here we have this real-time database in our Firebase project. Let's create the database. Here we have to select the data center. So we have these three options available. Let's select the United States and click on next. Here we need to start in test mode because it is just a test project. Now resources have been provisioned for our database and we have been given this node. It is the root node and it is set to null because we haven't added some data here. And from here at the top of the tab, here we have the rules where we can configure the different read write access. Now let's come back to the data. Here we will be storing our data. So it's null. It is the root node of our DB. Actually, the real-time database is a JSON tree. JSON is a JavaScript object notation in which data is stored in key value pairs. So the whole database is a key value pairs tree where we have this root node and then we will be creating the child nodes. Just like in MySQL, we create the different tables. So here we will create these child nodes. Like I create a user and then a user has different has different type of users with different IDs. Let me create an ID which can be like 1 2 3 and then every user will have a name. Let's give it a name Shah and let me add it. I can also add other key value pairs like age. I will give him an age as well. So I have created a user in this child node of the root node. Then it has another child which is the ID of a user, and then it also has some nested nodes which is age and name. So every key value pair is a node here, and it is the root node. Then these are the top level nodes that store the users. You can think of this top level node as a table in MySQL database and a collection in Firebase Firestore. Just like we created in the previous video. Here what I can do, let's add another top level node and call it products. That will store different products. Let's give it some ID and then give it a name. Let's call it Moringa seeds. Also let's give it a price as well. That will be a number value. I will give it 100 USD and let me add it. So here we have the top level nodes known as products and users, which are just like tables in MySQL and collections in Firebase Firestore. And then we have these the different instances of products which can be considered as rows or records in MySQL and documents in Firebase Firestore. So these are similar things, but the format is different here. And here I can create other users, other products as well. Let's give it some unique ID and then I will give it a name. Let's call it something different like tooth brush and also give it a price of $50 and add it. So here I have two products in the top level node which is products, and in the user I can also add another user. Let's give it a unique ID and I will also add some values or details of the user here. Let's call it a name Khan. Also give it an age of 20 and add this node. So here we have a root level node which is the database, which is a real-time database. Then we have the top level nodes which are products and users. Then we have the other nodes in these top level nodes which are the instances of these high level nodes. Here these are the different products I have in my app, and here I have the different users in my app as well. So that's how the real-time database data is stored, and the whole data is a JSON document. Let me export it to JSON in order to show you how this data is structured and how we are going to access it. So I will just open this and let's see. You can see it is a JavaScript object notation and everything is a key value pair. So our database is a JSON tree where we have the different nodes. That we have the top level nodes, then we have the low level nodes which are basically the different instances or products and users here in this case. So that's how data is structured and stored in the real-time database. Now I will delete this data from here and let's upload the data from the app. So I will come to my app. Here previously we have created a project for our Firestore database. Let's remove this Firestore from here. I will give it a name, real-time database, and we have the title changed. Here let me explain the UI a bit. We have this name text field, and we are passing this name controller here, which is this, and then we have the email text field where we are passing this email controller to take data out of it, and then we have the phone as well. So these three controllers will be providing us the data entered here, and then we have the four buttons for create, read, update and delete operations. When this button is tapped, this create, then we will be executing this logic here, and then we also have here for read, update and delete as well. So these are the functions we defined for the previous Firestore tutorial. Now we also created a database service that we are utilizing for Firebase Firestore. Here we will create for real-time APIs as well that will help us perform the CRUD operations. Here in the main screen, if you focus here, this is the DB service we are utilizing here, and this is the DB service we are utilizing for calling these create, read, these CRUD operations. So here I will create one for the real-time database as well, but for that you need to install this Firebase database dependency here in the pubspec.yaml, and then you can access, let's call it a real, and I will access the real-time database using this Firebase database dot instance, and I have created this instance of my DB. From here I can now create methods for performing different operations. This is the create for the Firebase Firestore. I will just copy it. Let's copy this create and create a new one for the real-time database. I will call it RL create for real-time database. Here I'm passing a user model. Let's go to the user model. It contains a name, email and phone. That is a user class, and we will be taking these values from these text fields, and it will create a user. Then this user will be converted to map using this function, and this map data can be uploaded to the database. So we will just create an instance of this user, and we will use this toMap function to convert it to map and then upload it to our database. So let's get back to the database service. Here we have this real, and we have the method created here. We are passing a user created from data entered here, and then we will be calling this method. So let's handle the create operation for real-time database. Here I will use this real to create a reference, and I will set it to users to create a top level node users. Then I will set a value for users. Here I need to provide a map which is in the form of key value pairs. Here let's give it the name Shah, and let's have a test if our operations work or not. Then we will be utilizing this user to upload data. So let me call this here on the main screen. Here in this create operation we will uncomment this, and using the DB service I will now create RL create, which is for the real-time database, and let's call it, let me restart the app, and now when I call this create, so the data which is here, name and Shah, it must be uploaded to the Firebase database, which is the real-time database. Let's see, we have this user being created, and then we have this name Shah. We don't have an ID here, so let's give it a child, and here we will be specifying an ID. Let's call it user1, and then I have set this data. So let's delete this data and create a new one. So now if I tap on create, so we will have a user created which has an ID user1 and name has been uploaded. So that's how we write data to the Firebase database. Now we will also we will be taking data from here, this name, email and phone, and then we'll be uploading that to the Firestore. Sorry, Firestore, not real-time database. So for that I need to use this user, and you remember we have created this toMap function that will create a map from the user instance. So let's come here and see. Here we have this user that we will create from the data taken in these text fields, and that data is going to be mapped to a map that will be uploaded to the real-time database. So we will do that. Here we will take this data from the text fields. Now we have just hard coded the data, and now the hard coded data has been removed and anything entered here will be uploaded to the database. So let's remove this old data and now create a user instance. Here I will provide a name Shah Wali. Then we have the email, which will be shah123@email.com. Then we have the phone, like 92307 and something like that. Now if I tap on create, this user will be created by taking data from these text fields. Then the DB service rl create will be called, and this user data has been passed. And here we are creating a top level node users. Then we are creating a user instance with this ID, and then taking this user data to map and uploading it to the real-time database. Now when I tap on this create, we will have a user created here. Let's upload this to see if the data has been changed or not. So let's wait. The data has not been updated yet. It's because we haven't saved this. So now let's try again. Remove this one because the ID is already there, so we will remove this one. And now when I tap on create, so let's see if the changes are reflected. Yes, you can see our user has been uploaded and we have successfully performed the create operation here. Now we also want to create a read method here. So I will copy this read for the Firestore, and here I will create one for the real-time database as well. I will call it rl read. Rl is for real. And now remove this data. We will use the real-time DB. For that, I will use a variable to store the data, which will be, let's call it data, and then I will use await because it is an asynchronous operation. Then use the real instance, and I will refer to that top level node. Then I will use the child to get to that children whose data I want to fetch. We can also fetch the whole users, but here we just have one, so I will fetch this single instance of user. And then I have our method known as once that I can use to fetch the data. So here the once returns this database event that we can use to print data. Here let's log this data. I will use this data, which is a database event. Then we have a data snapshot here, and here we have the children's, and we can use this children, and we can find out the length of this children's list. Here we will have the length set to 1 because we only have one item here. So let's execute this and see what happens. I will call it whenever the read is tapped. So I will uncomment this and I will use the rl read here now. So let's call the read and see what is printed to the console. So let's call the read, and you can, here we have 3. Actually it is because we have done a mistake here. We are fetching data in the user 1, which means the data will be fetched from here. Here we have 3 nodes, so that's why the length is 3, because each one is a separate node. We need to fetch the whole user data. So here what we need to do, we need to remove this child because we want to fetch the entire user node, which is 1. So if I tap on the read, you will see we have this one here. We can also print this data. So I will use this children list, and the data is fetched in the form of a list. It is a single node here, so I can use this index here and I can print it. Let's call it to string, and the operator isn't defined for the type iterable. Okay, it is an iterable. Let me convert it to list, and then let's use the first entry in the list here because we only have one. So when I read, it is an instance of data snapshot, and you can see here it is a list of data snapshot. Let's see if what we can do with this. We can also print a value here, so let's try it now. When I tap on read, you can see I have the whole data being printed to my console, and I have fetched the user we have uploaded a few minutes ago. So if we have a list of users, we can also use a loop to print all the users, just like let me perform that, and let's use the loop, and that will be integer equal to 0 I less than, it will be the list length. So I will use this iterable, and I will use the length, then I will use plus to increment, and here I can log all the users that have been fetched. Here we have only one, so only one will be fetched. Here I can use this I, and it will fetch just this single user. If we have multiple users, let's upload another one to see how we can fetch the different users there. So I will use this db service. Here I will create another user. Let's call it user2. Let's change the name a bit, and let's change this, and let's create another user. Sorry, I haven't saved this. I need to save this file, and here now let me call the create, and see, here we have the other user being created. Now if we tap on the read here, now it will be printing two objects. You can see here we have two data being printed. Let's open the console. Sorry, let's let's open it, and here let's call this read again to see what's the difference. You can see we have two records being printed here, but it's not being shown separately. We can also provide some spacing in the loop so that we can see the data. Here we will come to the main screen. Sorry, we are printing it in the db service. Here after every iteration I want to leave some space, and it should be like I want to print an empty line to differentiate both the users, because they are being printed on the same line in the console. So let's try it again, and I will add a read. Now you can see the different data has been printed here. The data is same. Let me see what's wrong with that. Yes, the data has been uploaded, which is the same. Let's refresh it and check that our operations have been executed successfully or not. So you can see our operation wasn't successful. Instead, the same object was created. We didn't save the file before uploading data to the Firestore. So let's delete this one and try adding another object. So here it will be user2, and we will map that user data. Here call it a different name, Safi, and let's change the email a bit as well. Let's call it Safi11, and this number to be changed as well. And now let's tap on create to create another object. Here you can see a different object has been created. Now when I tap on read, the two objects will be fetched. Here you can see the different objects had been fetched. So this is for the read operation. And now we also need to perform the update and delete operations as well. Now let's perform the update and delete operations as well. So I will go to the database service. Here we also have the update and delete. So let's copy these two methods. Control C, and here at the top I will create the real-time methods for these as well. So let's get it to the bottom, and here I will use the RL update to differentiate this method for the real-time database, and I will call it RL delete for the delete operation. Let's remove this line from here, and here we will be using the real, and then we will be using the reference to the users top level node, and then we will be referring to a child that we want to update. So it will be user1. Let's update this user1. Here I will change the name, and here I will use the update method. Let's provide a key value pair here, a map. It will be the name, and I want to just update the name here to Shah Wali. And similarly for delete, I will copy this line, and let's replace the Firestore line with this one, and here I will call the delete method to delete. Sorry, we have the remove method here that we will use. So we have also set the update and delete operations that we will use from the main screen. Here with the update, I will uncomment this line, and I will use the RL update, and here RL delete. Now when I tap on this update, then this name should be set to Shawali for user1. So let's tap on the update and see. You can see the name has been changed to Shawali. And now let's try the delete operation as well. Whenever I tap on this delete button, So this node should be deleted. Let's try it out and tap on delete, and you can see this node has been deleted. That's how we perform the create, read, update, delete CRUD operations on real-time database with Flutter. But you may be thinking, where the hell is that real-time thing? Because we have just performed operations, but there is no such real-time thing in that. So don't worry, it's a real-time database. We can also listen to things in real time. Here, let me replace this read operations with the real, and let's call it real time read, and it will listen to the any database changes and will fetch the data accordingly. It will be listening to data in real time. So let's remove this loop from here, and instead of fetching this data once, let's get a stream of that data and listen to it. Here we need to remove this as well. Now we need to listen to that data. I will call the data dot listen. We can listen to streams, and here on value returns a stream of the data from here. So if anything updates there in the DB, the data will be fetched here. So we can listen to that, and it will be sent here as an event that we can log here. We can use this event dot snapshot dot children, and we can log any value from here. Let's log the first value from the children list and use the value here, then print it to string and add a semicolon here. This children is an iterable, so we need to convert it to a list as well. Whenever there is a change in that data, it will log the first user. Here we have in the list, in the console. So let's update something here, but before that we need to execute these lines. So in order to execute these lines, we have this dbservice.rl read here. We need a real-time read now, and whenever I call this read, this function is going to be executed. That will get us a stream, and we can then listen to that stream, and whenever there is a change in data of the real-time DB, this event is going to be triggered and this callback will be called. That will simply just log the first user in the list of users and to the console, so that we can see the changes. So firstly, let's call this read. It will register the stream here, and you can see first time the value has been fetched. Now let's update this data to see if the changes has been reflected in real time or not. So I will just change this data here. I will make it co and save it. Let's see. You can see this method has been triggered as there has been the data has been changed in the real-time database. So the data has been sent to the console here in real time. So that's how real-time data streaming works. Similarly, if I add another user, it will also print this data, but instead I want to print the length of the list. Currently we have the length which is the one, because we just have one user there. So if I restart the app and I tap on read, so we will have this one printed here because we only have one here. And whenever I change some data in the DB, I create another user. So as we are listening to that data in real time, so this callback will be triggered and it will print the updated length of the list. So that's how real-time listening works, and streams come into play. So let's add another user here. I will call it user 1, and here let's give it an email, something like blah blah at email.com, and add it. So you can see here this has been triggered and we have the updated length fetched here. Similarly, we can fetch the updated list of users as well. So that's how real-time listening of data works, and you can listen to the updates in real time so that you can update your UI accordingly. That was all from the real-time database. We can also perform this real-time listening of data in the Cloud Firestore as well, that we will cover in some later video. That's it for today's video. See you in the next video. Goodbye.